So what we're going to present today is, I'm not going to do much of the presenting, but the people with me are going to present. We wanted to take the same case study and then walk through it with different tools. So the analysis that we took is looking at the 2022 Pakistan floods. And what we wanted to do was basically answer one relatively simple question: is within the floods that happened in the summer of 2022 in Pakistan, how much area was flooded? So it's a relatively simple question that can be answered with remote sensing. And it's also kind of a legitimate question to ask when we hear these stories about there's a flood, there's a story like this. Remote sensing is a pretty cool tool to use, but there are many different, again, tools that we could be using. And so what we'd like to do today is explore different options. So today with me, I'm pretty excited. We've got some pretty cool people. So we've got Qiusheng Wu, who's the creator of geemap and leafmap. You might have seen as well, he does a lot of tutorials for Google Earth Engine, a lot of academic work as well. Then we have Bonny McClain, who's the author of the newly released Python for Geospatial Data Analysis. There we go. Bruno's showing that. Can I? Oh, okay.
Oh, sorry, I'll put it again. Yes,
yeah,
let's
do it again. Let's show the book. So it's the new O'Reilly book that Bonny wrote, Python for Geospatial Data Analysis. And then we finally have Bruno Sánchez, who used to be the director of Microsoft Planetary Computer and kind of started the project, but no longer is at Microsoft. So this kind of started, just to set a bit of context, this started as something that we decided to do. We don't have really any affiliations with these tools. Some people have worked on them, but the idea is really to kind of showcase what we can do with all of these. So how this is going to go is that all three are going to go through the same analysis, and then Qiusheng is going to show how to do it in Google Earth Engine. Bonny's going to show us how to do it in QGIS, and finally, Bruno's going to show how to do it in Microsoft's Planetary Computer. These analyses are not going to be like super complicated or anything. We're going to try to keep it at 15 minutes per person to try to keep it to the point. If you do have any questions, please put them in the chat. We would be excited to answer those. And with all of that said, I think we can get started with Qiusheng.
Okay, can you hear me?
I think we should be good. There's a little bit of delay with people, so I think we're going to be based on the assumption that people can hear us.
Okay, sounds good. And so I sent the link. Maxim, if you can send the link to the audience, it would be great. The link to the notebook. And so here is the example that we're going to go through today. Basically, I'm going to show you how you can do some quick image analysis using Google Earth Engine and geemap. And everything is reproducible, so you can go to the link that I'm showing you here. And so if you look at the web page, it's actually interactive, so you can actually scroll down. I also have some like short animation show you how to do that, but I'm going to quick go through step by step, show you how to find the data and how to create some simple image composite and how to do some simple analysis to extract flood extent. So I would like to point out that so it's not going to be super scientific, not very precise, but I'm just showing you the step. And certainly algorithm you can refine, you can make it much better. But I'm just showing people that if you don't know how to use Google Earth Engine, or if you're not familiar, how you can actually get started from the very beginning to the end to get some statistical results. So you're welcome to go through the map, and you can zoom in, you can zoom out. You can also maximize the map if you want to. So, but at the beginning here, I also show you the requirement. Basically, you need to sign up for a Google Earth Engine account. If you already have one, perfect. You can follow through using Google Colab. If you don't, you can just scroll down the notebook and then follow the steps. You will also be able to actually watch and interact with the data. Okay, so let's get started. And at the top here, I show you a couple links that you can open using Google Colab or AWS SageMaker Studio Lab, or even Planetary Computer. So you can actually run it on any cloud computing platforms as long as it supports Jupyter Notebook. So just right click, and then it should open in Google Colab. And let me maybe zoom in a little bit so you can see better. So once you open the notebook, then just simply in the first line here, you will need to uncomment this one. So what we are going to use in this tutorial pretty much is using geemap. So geemap is the package that I created to do interactive mapping and data visualization with Google Earth Engine using the Python API. So just click the play icon on the left side, and then run anyway. So this would allow you to automatically install this package. So everything is in the cloud, so you don't really need to install anything on your computer. It's using the Google Colab. So it's just a Python environment that allows you to do coding. It might take a couple seconds. So upper right corner here is going to show you like connecting. So initializing, and then it's going to take a couple seconds to install the package. So this is just one step. One time after you finish the installation, then you should be good to go. So, and you're welcome to set up this one on your local computer if you want to. I also have a tons of videos showing people how to use geemap. You can check out my YouTube channel. And so if you wait at the end, it shows that the package has been successfully installed. Then we can continue to the next step. So this is okay, it's all done. And if you want, you can click the upper left here just to clear the output so that it don't take too much space. I can actually, let me clear all the outputs. Okay, so once we have installed the package, then just import the library. So these are the two primary ones, the Google Earth Engine Python API and also the geemap, right? And after you finish the importing the library, then we can start creating the map. So here, let me uncheck this one so that it doesn't show you the, let me delete this one so it doesn't show you the animation. And so the first step, what we want to do is to create an interactive map. So the map, you can initialize with the map center and also the zoom level. If you don't know them, that's fine. You can just simply, just like that, you can create a map easily. So the first step, you also need to authenticate because Google Earth Engine, you need to authenticate before you can use that. So just click the link and make sure that you have signed up for Google Earth Engine account, and then create a cloud project. It's all free for research and education and no profit. So it's, but you just need to sign up and create a project, then create generate token, and then log into your account, click allow, and copy the authorization code. And then you can come back to Jupyter Notebook and then just press enter. Again, this is also just a one-time process. And once you have authenticated, you can just simply, from here, if you run again, it won't ask you for authentication. So this is the simple steps to create a map. That's it. And once you have the map, then you can navigate to any location you like. And the next step I'm going to show you is how you can actually get the data, because we need to have the data so that we can get imagery or vector data. So upper left corner here, if you click the icon, this show you different tabs. So you can search by location, by coordinates, or you can search by data. And the first step, what we want to do, because we are going to do the flood mapping in Pakistan. So we need to find actually the boundary, country boundaries of Pakistan. So you can simply click the data tab. And then from here, you can search whatever data you want. So Google Earth Engine has over 70 petabytes of data. And let me scroll up here just to show you quickly. If you go to the Google Earth Engine webpage, and then here, this is all the data set that Google Earth Engine has, and it's a huge database. Just think about any streaming services, right? It's a huge movie database. So it's just search movies by the name or by the keywords. And then from here, you can find out, for example, navigate to any data set. So we are going to use Landsat, Sentinel. So for example, there are different types of data sets. So you just click through if you want to. It's more like a hierarchy. And then, so for example, surface reflectance. Once you get there, on every data set page, so this is the ID, so basically the unique ID to the data set. And once you have that ID, we can retrieve the data. We can do all kind of computation if you want to. So this is, I'm going to show you later. But for now, let's go back to the notebook here. And so the first step, what we want to do is just to, for example, type countries. And then just press enter. Oops, let me try again. And once you type the keywords, it will show you the list. So for example, here, there are a couple data sets within the Google Search Engine database that allows you to retrieve the data. So I'm just going to click the last one here, simplify. And you can take a look at here. It has a link. So if you want to see the data set, click the description. It should take you to the web page. So basically, this is the international boundary polygons. And once you have that, the next step will be how we can actually load the data into the map. So you just click the import button, and it's going to show you the Python code examples. And if you're running this one locally on Windows or Mac, it's automatically copy the code to the clipboard. But Google Colab doesn't support that, so you just select and then come here, create a new cell, and then just Control V, right? So Control C, Control V, and then just run the data set. So boom, you see now the data set is within here, and this is loaded using the so-called feature collection. Essentially, it's a vector data, and this is how you want to visualize the field color, the color, and also the width. You're welcome to change that if you want. So I can say, for example, field color, I can, maybe if you put 80, it's going to be transparent. And so the color here, I can make, for example, red color. You're welcome to customize to whatever way you want. And this is how you actually visualize the data. Upper right corner here, you can click this one, and you can turn the layer on and off. Okay, you can also change the opacity if you want. So this is basically geemap helps you to visualize the data very, very easily. You are welcome to search any other data set. So there are tons of data sets in there. So I can, for example, search Landsat, right? I'm going to show you more examples later, but if you see, right, there are tons of data sets that build on top of Landsat. So you can just click, select any data set, import, and then here, you should just simply copy the code, and then create a new code block, Control V, run, enter. That's it, right? So now you have, this one is the another polygon, right? Settlement footprint. But we are not going to use that, but just showing you that you can source data set and add them directly. Okay, so once we have that, let me quickly go to the next one. Is that okay? Because we are going to do Pakistan, so we need to specify the country name because in this data set, it's the global. So you just need to filter the data. We're also going to use the flood basically in 2021. So this is before the flooding, and this will be during the flooding period. So we're going to use data from August to September. So basically 2 months. And once you have that, you can start filtering the data. And again, this one doesn't really matter, the location and also the time period. You're welcome to customize this to other locations. So I'm going to quickly, because the time limit, I'm just going to quickly go through here. For example, we filter the data, we select the country Pakistan, and then we sort it on the map. Once you have the boundary, then we can start creating some imagery composite. So in this case, we're going to use Landsat 8 data. And let me show you here what it looks like. So I'm going to create actually these two code blocks. So the first one is the Landsat composite, right? So this is the Landsat 8 data, and I'm going to filter the data by these 2 months in August and September 2021. Also filter by Pakistan. And then I'm going to use the function to simply create the composite and also clip to the country boundary. And that's it. And then do the visualization. So if you scroll down, now you should have these two images. And again, you can turn on the layer control. You can see the differences. So if you want, you can zoom in to the area. You can clearly see the flooding. So this is very, very useful because if you have to go online to download data individually, it's going to take you hours. But now just two code blocks you can actually show the data just a couple lines of code. Now you can have access to the data for the entire country, or even at the global scale. So it's up to you what you want. And you can also create a split panel map. So this one shows you we have 2 data layers and have one on the left, the other on the right. And this allows you to use the slider to see the changes like this, right? And you're welcome to explore. You can clearly see the flooding, right? On the left side is on the Landsat 2021. On the right side is Landsat 2022, right? And you can also turn the layer on and off if you want. So feel free to explore. Once we have that, then we are going to extract the water. So in terms of the optical data, the normalized difference water index is commonly used to detect water bodies. So this is the equation, pretty simple, right? Green band minus the near infrared divided by the green band plus the near infrared. As I mentioned at the beginning, the algorithm just to show you the simple step, but you can make it very complicated if you want. But in this case, we're just going to simply use the NDWI. And so we're going to calculate the NDWI, and then we can show you the NDWI layers. Also, you will see a lot of maps here, a lot of lines of code, but I'm just trying to separate each step so you have a map for each step. But in reality, when you're doing the project, you just need one map. You can add all the data layers just to one map. So all the lines that I'm showing you right now, it can be condensed to maybe 20, 30 lines, and you can get the work done. But here, so now we have the NDWI, right? So the normalized water index. So you can see the changes. So basically, the darker color represent water. The brighter color represent non-water. So you can clearly see what is happening in this area. Once you have this one, because the NDWI is like a range from -1 to 1, so we can simply use a threshold. Usually, positive number means water, but there might be also some other, for example, shadows and cloud, other stuff might also cause to have some positive number. So you can add a slightly positive number, for example, 0.1, 0.2, whatever. And so anything greater than 0.1 is to be water. So what we are doing here essentially is to convert the NDWI imagery to a binary one. So yes or no. So water or non-water. And then you can visualize that in different colors. So in 2021, we are going to use blue color. 2022, we are going to use red color. So if you see here, right? So now you can clearly see the differences between these 2 data sets. And then you can extract the flood extent. So just minus the first year minus from the second year. So if the first year is not water, and then the second year is water, then we are going to identify that one as the flood extent. So you can clearly see right now the cyan color is the flood extent. So basically the newly flooded area in 2022. So you see if this blue one is water in 2021. So the red color is water in 2022. And now the cyan color, this one is the water in inundated area in 2022. And after that, you can run some simple zonal statistics just to show you the inundated area. So what you need is the water area, the country boundary, the scale, the statistical types. And then because the scale is like 1 kilometer, so the result will be square kilometer. So this shows you the result, and this will be the, for example, the final inundated areas. And I think it's kind of already run out of time for my section, but I also provide the SAR data. You're welcome to explore it, but the step is pretty much the same. I can show you quickly if you want to. So we're going to create a simple composite for SAR data. And so 2021, we're going to use the VV polarization ascending. And so SAR data, because it's like not affected by cloud and weather, so it's 24 hour. You can unlike Landsat that is affected by cloud. So this is really nice for mapping floods and water bodies. And so, but it takes some time to also organize the data, but the logic is pretty much similar to Landsat. And then once you have that, we create a composite. One thing that additionally we need to do usually is to apply a speckle filtering. So because sometimes it can be quite noisy, and once you do the filtering, it becomes a lot more smooth. And then you should be able to to create a composite very much similar to the Landsat, and then you can compare the data set side by side. I don't have time to show you in detail, but after the imagery, you can do the binary. So here, just show you like, so the black color basically is water in the SAR data set. So you can clearly see the changes between those 2 years. And after that, pretty much the same thing. So I can just run here, run after. So just quickly show you the results, and the logical steps are pretty much similar. So you get the imagery, you do the composition, and then you create some indexes to extract water, and then you can create a binary, water and non-water. And then with the 2 years, you should be able to create a difference image showing you what's the newly inundated area. And so all the images, all the data, all the source code reproducible. So you're welcome to try it out and adapt to your area. I don't want to take too much time from here, but yeah.
Just to wrap up, do you have a comparison of the number between the optical and the SAR?
Yeah, so on the left side here, if you click the table of contents, so I can show you, for example, extract Landsat flood extent or compute Landsat flood area. So here, the difference would be 11,000 square kilometers using Landsat. And if you use the SAR data, it's 12,000. So, I mean, the number sometimes it might not be very accurate. It depends on the threshold, depends on the scale, and it also depends on the threshold or the images composition that you created. So, but it might be pretty much similar to this one, but will not be exactly the same.
I think that's pretty interesting thing to compare, that even with the data, like changing what data we use, regardless of the tool, leads to a bit of a different result.
Yeah, just, I mean, the important thing is to like what kind of workflow from the very beginning when you have the research question, where do I get the data, and then how do I do some manipulation, and then how do I report the results. In between the algorithm, like everyone can come up with a different algorithm, so you can make it really complicated. I'm just trying to show you some simple steps that everyone can understand, and you're welcome to adapt the notebook to your area or other time periods. It doesn't really matter. So the location and time period doesn't matter as long as you have the data. The
code for that is in the chat for people who want to check it out, as well as a link to Qiusheng's YouTube channel. Once the live stream is over, I'll also update the description of this live stream to have the link towards everybody's projects. But we're gonna move on now to Bruno.
So just to clarify, the live stream will be available afterwards for anyone to watch it again. Yep. And I think actually the second one, I think, is Bonny, right?
Oh, sorry. Yes, my bad. The next one is Bonny. I was just trying to see if you guys were paying attention. And yes, so
yeah, I call it the rose between two thorns.
All right, so now we're going to move on to doing pretty much the same thing, but in QGIS. And so, Bonny, you have the floor.
Yeah. Now, when we say the same thing, I like to qualify that I work in stories. I like to call myself a geojournalist. And just by coincidence, dengue fever was something that I was working on. And when we were talking about this region, I realized I needed to start somewhere. So I'm going to show you just a few quick, easy data resources so you can get your data into QGIS. And what you're looking at right now, you have to, this is Earth Explorer. You have to get a account, but it's easy. Everyone's in. You just have to sign up and then you can save your data. So all I did here, I saved the criteria here so we can, move through it. But you do your search criteria. This is actually tagged with Pakistan, but you go in world features. These are all loaded with different things. You can do states, you can do, global features. You can pull in a polygon, you can pull in a shapefile. And what's really convenient here is you can adjust date ranges. So if you're looking at a specific moment in time, like we are here, then you're all set. And then we go to the data sets, and I just want to show you here, you have quite a few data sets. This is the one that I was using. There's many, many deeper, buried through the linkage here. And then what you do is you get your results. So it'll find a result for you. And if you know that you want to be in a certain region on your main map, this is kind of cute. You just hit a little toe, a little foot, and you can see if it overlaps the area that you want. And then once you find the area, like something like this would be great. You can look and see if it's cloudy. You can look at the area here, look at metadata, and then you can just download it. So this is kind of what I did for 2 different time frames. And then what's really neat is Sentinel Hub. They have one that's a little more, I think it's a little more like fancy schmancy. You can really easily, it's faster. You can get Lorcana. You can actually do comparisons in here. There's a lot you can do to visualize data in the Sentinel Hub as well. And then when you have an actual question, like we're looking at, I do a lot of work in environmental and climate change. I want to see where these things are happening. So I found data for that region in Pakistan and the flooding really just by going in here, looking in flood, putting in a country, looking at different dates, and then you find your bundle and then you just download it. And similarly to that is this one here, GDAC. So basically, because I tell stories, I want to find out where things are happening in the world. And I had to do a search for this, but these are things you really should remember, your EMS risk and recovery and GDAC, if you're looking for this sort of data. And now we're going to go to QGIS. And, I loaded it up just for the sake of time, but I will go back to, I'll close some of these down perhaps, but I do want to show you when you start in QGIS, you're going to have a blank. It's just going to be a blank canvas. So what you need to be able to do is to find your data. And what you do here is this is how you find a map. You can go to Quick Map Services. You add it as a plugin just to give you a peek at all the plugins. These are all the plugins that I have, like all of these. And there's many, many, many more. But just through working, through your own workflow, you'll figure out what you need. And the Quick Map is one of those plugins. It shows up under Web Map Services. And what you can do here is when you load it, if you go to your settings and you hit more services, you'll get that long list that you saw when I went in here, and it'll populate your map. So then you'll have a big map like the one you see in the background here. And you go down, if you look in the bottom lower left corner, where you see Lorcana, that's one of the regions. There's a nominatum OSM search bar. So if I put any place in the world there, it'll now focus my map to the region where I want to be. And that's kind of the point to all of this. And then you have other resources. I'm showing you these because you're seeing the product of a bunch of it listed in my layer panel. So you have a browser panel. So wherever you download your data files, like the ones I showed you earlier, wherever you downloaded them, you can easily just pull them in through this browser panel. And what you'll do when you have your blank canvas is you'll go to panel, and then you can load these. So the little blocks you see on this dashboard, and it's kind of busy now because I'm building things, but you can take them off, you can move them around. I like to have layers, layer styling. There's a processing toolbox. There's results, there's statistics. There's a lot here that, in this introductory foundational chat, we're not really going to get to, but that's how I got my screen to kind of look like this. And it just is reflected what I loaded in. As soon as I load it, it lands in my layers panel. And that's what you're looking at here. And then you can see where I started the journey. This here is Lorcana. And what you're seeing is the infrastructure. I start with infrastructure, and I'm going to end with looking at the changes in the water volume. But I do think it's important when you zone in on an area to have a feeling for where you might find more data. So what you see here in these lines here, these are all the transportation, railroad, road. You can see where these little purple things, these are where people are living. So these are buildings. So once we start building out the flood data, you're going to see how it's impacted the communities. And when you're, really exploring beyond just looking at the changes in the water levels, you can actually see, where there's a residence that might be underwater now. You can look at land use, because a big part of the story was complete wipeout of agriculture and, the farming and the grazing and the structures and the roads that were washed away. These are all really important stories to include when we're looking at areas. Now, over here on the right lower, I've already loaded this data, but this is a really cool feature. And I'm going to move this just so you can see this, because there's several options to get Landsat and a whole variety of data, different data types into your database. There's Google Earth Engine up here where I can go and upload data right from Google Earth. I can put that Landsat data and it'll show up right in my screen, right in my canvas. And you can also picture a moment in time and screen it and filter it that way. A lot of people don't realize that QGIS isn't just a portal. I mean, you have integration with a lot of different data sets. Something that I use an awful lot is this one here. It's the cloud masking. This is the little sign. But if you go down here, you can load in the data directly from that Earth Observer data that I downloaded. I can pull it in here. I can load it in. And what I did, and you'll see that these are over here, and you're gonna look at those in just a minute. But those are the files that load in, and you can pick your bands that you want to visualize, or you can pick the pre-bundled natural color, false color, infrared, and it'll add it right to the map. And one more thing that I do like to show people is you can also set your canvas extent and get down and download, topographic, DM files and SRTM right here, and they'll show up on the map as well. You set up your Earth Data account. They load up for you, and I'm not going to do it here, but I'm going to take them off now because I don't want to overtax the system. But you can take the ones that load and you can create like a virtual layer on these, and then you also have that information that you can add to the story as well. And a lot of people don't realize that that's something you can do right inside of QGIS. And for our purposes, in fact, let me just take these off just so we can now, when we get back to looking at, let me open this so we get a better view. So what you're seeing right now is the river. I can make it a little bigger. And what I like to do is we're going to look at, first, let's look at June. So data that I downloaded was from June. So when you look in June and you look here, you're looking at the infrared, so you can see the color, you can see where the river is, you can see where the hydration is, you can see how this area looks. And then what you're able to do is add, now that looks dramatically different, and it's the same, it's the same bands, it's just the end of August. And we can do a slider over here as well. And, you can zoom in better, and this is quite dramatic because of the color. This is saturated, but I mean, you could change any of these. You can change to false color. You can change the color, but if you're just looking to see, the dramatic change, that's right here. And then when you want to look at the data underneath it, the data, when you load it and create, you can, polygonize rasters and you can find data. There's the attribute table. Turn that off. Now, if you open up attribute tables, which is really important when you're pulling in, some of this data, you can actually see how they've coded the data. So you know how to filter and how to see and how to measure. So right here, they're looking at, the water increases. But like I teach people, when I'm doing presentations, you have to look at the data that accompanies what you're looking at. And these attribute tables that you can open right inside QGIS let you know what you're looking at. You can look at validation codes. You can see if the data you're looking at has actually been validated. I mean, that's extremely important. And then we can look over here. And, these are confidence IDs. Yes, it's kind of squishy with very high, medium, uncertain, but you can get a little bit of, qualification. And then you have the water class over here. And this is also showing you how they've filtered through the data. So now when we go to our data layer and we want to know, so if I turn these off, and you want to look at these are the polygons that we were talking about. So now it's loading, probably loading slowly. But if you wanted to look at the extent of the flood, once you pull it onto your data, which is going to be this one, which is kind of hard to see because it's all blue. But if we open it up, there we go. We're going to go to the attribute table, and this is where we find our data. So in here, depending on what polygons, what area, and how we focus and where we are, we have a calculation waiting for us. This one's in meters squared, not kilometers squared, but you can kind of do the math and figure out it's in the ballpark, because it was quite a broad ballpark that we had in terms of, like, I think Qiusheng was saying, depending on the area you're looking in, depending on how you capture it, depending on, those categories that I was showing you that they list, it's important to know what they are so that you can kind of decide, is this a single source of truth? Are you able to apply this data to the other data that's out there, out in the world? So I feel like, unless there's a question specific to here, right at 15. Is there anything?
Yeah, I'm just gonna jump in here to say that if people do have questions, please feel free to put them in the chat. It can be about anything that we've talked so far, even if it's something about Qiusheng and Google Earth Engine, something Bonny just showed here in QGIS. Really just feel free. So we have Philip just asked, like, how was the analysis actually done? Like, I think on the, how did you get that raster layer, that polygon layer, sorry, that you just showed, Bonny?
Oh, the polygon layers were, if you had noticed when we went to the disaster site to get the areas, this was kind of early on, they release a lot of this polygonized data for you so that you can, because this whole area, people were interested in different provinces, for lack of a better word, and this data was released in this province. So that's why I thought it was really important that we listed out how they calculated the data. So they had field stations that went in and looked at and categorized the water, based on, was this flood water, was this, with the extent. So that's why I was showing these. So those, I guess, what do you call them? The CSV files, because they talk about how it was calculated. And I think I put it in GitHub, the data that supports how they did those sorts of calculations in there under the hood, if that helps.
Right, so that's taken from the Copernicus Emergency Management Service.
Yes, I did some raster calculations of my own, but then I had to go into Excel because they did the pixels and they had like all of the values. And so when I added them, so what I did is I took that I got right off of here by doing raster calculations in the toolbox. Let me just show you where that is. Unique values report that you pull data into. I just had to write a little bit of a code. It was a SQL code that I wrote just to add it all up, and it was right in that range. So I wanted to show you that, you could step into QGIS and get some answers. And then, depending on your skill set, you can also come in and, write your SQL, if that's what, use Python. There's a Python plugin here that I've used numerous times to do like the mathematical calculation. And those I did, but I had to pull them over into Excel, and I didn't think we were going to do all that.
Yeah, that's why I'm just bringing up. We have a couple questions here. It seems like people are just getting a little bit confused as to like if the analysis itself was done in QGIS, like the getting that area number, basically. It seems like here it's more about presenting the analysis that's been done based on the images that you showed earlier, but in this case, it's done by the Copernicus.
Yeah, I mean, I can run it on what's sitting here right now, live, if we have a second.
Yeah, sure.
But I mean, this is also being done.
Can you just walk people through what you're doing right now?
The raster layer unique value, it generates a table. So you can see right here how it's looking at the data, the input. What the input is coming from that. The input I put in was that raster layer. So you can see where it takes it does a pixel count. It looks at, the data, and then it generates what you'll see right here. And it does, it adds all of this. So there was I didn't write any code for this one. Does that make sense?
Yeah, and so this, what you're showing here is all the counts of the unique pixel values in the image.
Yes, and then it's that actual layer. It's the layer, you pick the layer. You can pick the layer from whatever date you uploaded, from whatever area. You can create your own mask, you can create an extent, and then you can calculate that from there. Does that make sense?
Mm-hmm. And so then you'd compare those two with the two different images, basically.
Yes.
Mm-hmm. I'm going to round it up here just so that we can move forward onto Bruno with the planetary computer. But if there are more questions, please keep putting them in the chat. We can come back to them in a little bit. So Bruno, I will pull you up, and then there you go. Yeah. All right. Okay. Take it away.
So I'm gonna do the same calculation as we've seen with the Google Earth Engine on the Qiusheng's IDE on Python, and I guess one thing to highlight is that Google Earth Engine has more than like a decade, and QGIS 2. The planetary computer is something like 2 years and change the years old, so it's being actively developed. And so when you go to use it, might be different. You go to planetarycomputer.microsoft.com, and you do need an account for some of the things, but not for others. So that's why I'm not gonna log in yet. So you have a data catalog. In essence, broadly speaking, it has kind of the same data, open data, that you might expect in Google Earth Engine on AWS open data. The usual suspects are always the same: Sentinel, Landsat, and others. And the Explore tool is the one we're going to use. I have not logged in yet. Anyone can go to planetarycomputer.microsoft.com. You can zoom into Pakistan because it's the area we are interested. And then I'm gonna use a lot SAR because that's the one Qiusheng didn't have didn't have time to use before, but we could also use Landsat, or you could use Sentinel. Basically, you highlight that you want to see the radiometrically terrain corrected, and we can go into details later what that means. But basically, this is data from, this is the most recent because I haven't done anything, most recent data from SAR. But because we are interested in seeing what happened in Pakistan on the floods, I do remember one of the dates. So basically, this is what I do when if I had to do this question from the beginning. Okay, let's go to explore. I know it happened around August 22. I'm just gonna go to see how the data looks like. And I select on the filters between dates. I don't care when it starts, but the answers stops in August 22, 24th, and this, okay, there seems to be here some flood. I don't know if this is normal or not. So I'm gonna pin this layer. I'm gonna add another layer, which is the advanced filter. I'm gonna use same in year before in August. That was 26, same data. And now I can select here. Okay, yeah, definitely. This is 2022. This is the year before. What you see there is being rendered on the fly, the latest results. So that's why I'm just toggling back and forth. You can also do that slider thing. You also have individual scenes that you can click and take a look at that. You can even get the URL to add, for example, in QGIS or in other places. And you can also go to results and you can see what's the extent of that scene. This is the extent of the scenes, or you go back to where you were looking before. Basically, you get the idea what you can do. You can also you can pin this one. There are other layers, like for example, I want to see where actually people live. I know there is another data set from satellites at night. So you can see, okay, so this is where basically people live mostly in this area. So I know that this is the area where was the flood. I'm going a bit quick here to not use a lot of time, but basically I can then make this half transparent and see that that year there was not the flood that affected this city, Seville in particular, and Dahar. And I basically can take a look to the data and see what's the, how does it look like? Oh, that was before there. This is with the flood. And basically take a look at how the data looks like. Once I'm kind of happy with what I'm looking at, I can also share the link to anyone so they can see, get the same status as I'm seeing now. I can even go here on the edit layer. This is the one for the flooding, and I can generate a quick image. And basically, it generates a snapshot of the resolution that you want. Just takes a few seconds. Or you can also click on time lapse, and then basically you can create a time lapse of, I don't know, let's say this area. Whoops. Go slowly so that I can do it. And this time lapse is going to start in 2022, in, let's say, in July. And then let's do every week. I want to do one lapse. I want to do, I don't know, 12 frames, and then generate animation. And it's going to, I'm sorry, that you should work. I don't know what didn't happen, but basically that you would basically, you will get a, let me just try again to see if that happens or not. We're in area 2022. This is live coding. These things happen. I said the start in June, and it's every week. And I'm gonna do 12 frames, and I generate. Okay, sorry, that didn't work. Basically, this should work for you, and you get a nice GIF animation. Now, when you start coding, and you get here a glimpse of how to start coding with this data, like we did with the Google Earth Engine. This is the data to pull out exactly the same results. And you do that in the hub. This is the compute environment. You need an account, and you basically request an account here. Is there's no cost to use these things and to use the compute environment. And when you start the compute environment, this is literally a Pangeo stack with all the Jupyter, Python, R, all of these things. And you can even choose an environment with GPUs, not GPUs. You can even choose a QGIS on the cloud. So basically deploys a QGIS environment or any of those environments on the same data center that all the data is. So basically now we're going to start a compute environment. Now, this compute environment, like Google Earth Engine, is free of cost. It's in some ways a bit limited, that because you're using the same resources as everyone else, but because it's all open source, you can deploy your own Pangeo environment or whatever thing you want to deploy, that as long as it's on the same data center as the data in West Europe, then you can use whatever you want to use to do the compute environment. So after you wait a few seconds, now my environment is set up. You are familiar with this probably, and this is the code that I created. Basically, I go here through all the motions, and you can read this, how I go to explore to get the data. One thing I noticed, which is something that I'm also talking with Qiusheng and everyone else, is that if you look at things in RGB, there's clouds and also the flood. This is the same area in RGB or for NDVI or others. This is red, green, and blue. The flood, it's apparent that this is flooded and the upper part is not. But if you look at that in SAR, in synthetic aperture radar, it's very, very apparent. And the reason is that the signal back in SAR is very much not there if it's water, because standing water has mostly a specular reflection. And indeed, the two modes of the synthetic aperture, the sending in vertical polarization and receiving in horizontal, which is basically volumetric or surface scattering, does not happen. But if you send and receive from the same polarization, you see a dramatic influence, dramatic visibility of that standing water. That's why in my analysis, I'm only asking for the SAR in this channel. But again, what I did is I want to explore. I took a look to the data. It was very apparent that I could use synthetic aperture radar with Sentinel. So I then checked on VB and I saw that I could use this thing. And now I'm doing the compute. Only one more note on the compute to highlight that I can do it like I'm doing right now in the browser of the Planetary Computer Hub. I can also use my IDE of choice, like Visual Studio Code, and then I connect the server to the Planetary Computer. So basically now have my IDE here with the GitHub Copilot and all the things that I like to do, but then the actual kernel of Jupyter is a remote one in the PC. I can also do exactly everything local and then deploy. This is what you see. You can see in the code that you can use the VS Code as I'm doing here with the compute in the Planetary Computer. You can even deploy your own thing, or you can also use it locally and then deploy a Dask environment, which is the thing that crunches the numbers in West Europe, and do that crunching there. You have the code all basically all here. But the key insight that I want to make clear is that the data sits in one place, is very well cataloged, as you can see on the Explore here, on the Explore. Again, and I know I have 5 minutes left. So basically, you have all the data cataloged in the Explorer, and you can take a look at that, and then you compute. You can compute with whatever you want. You want to compute in R, compute in R. You want to compute in Python, in Python. Indeed, there is no single environment to use the Planetary Computer. So the rest of this exercise is just my skills, my limited skills coding in Python using Dask and Open Data Cube, because it's the tools I chose to use. I could use other tools, but basically I use a PyStack client to get the data, this is the code that I got from the Explorer. And I also, this is what I mentioned before of spinning up a Dask cluster with all the resources. It's basically a few lines of code, and then you own that compute, which is under your full control, or you can use the one which is in Google. if you are not using the compute set up by you by the Planetary Computer Hub, you need to set up the token. Actually, I'm going to just use this one. So I am going to, I think this is my one. I only have 4 minutes left, but I wanted to set the credentials for Azure to upload the results. But now, as I said before, all this stuff is normal Python. I'm using the Pakistan borders of the country, and then I'm plotting them. And because I'm going to be calling the API for the results that are inside Pakistan, I make the hull so that the query is not that complex. And then I plot that. This is the Pakistan one. And I choose the interval of the flood in August to September. And then the year before pre-flood, I choose the resolution to work with as 500 meters, because the higher the resolution, the more compute you need. In this case, I was happy with 500 meters. And then what I do here is do the search in the catalog for Sentinel-1 SAR data that is on the range of the dates. And I get 500 results back, and then I use Open Data Cube to load that basically into a pancake of data for the VV bands only, because the one that I'm interested on, and then I get this back. This happens really quickly because it's only setting up the environment. And then I make the minimum value over the flood period over time, basically when there is flood, and I make some average rolling in latitude and longitude, the 2 pixels, to kind of also, like Qiusheng mentioned, to remove a little bit the speckling that you can see. And then this compute, I'm going to wait for that. But basically, this takes not as short as the Google Earth Engine. Is absolutely amazing that Google Earth Engine makes this in like 2 seconds. This probably takes 10 seconds, 15 seconds to do. And then I saw it. There you go. Here, I'm plotting the results here. This is the results of the minimum of synthetic aperture in VB over the flood period. And you can see the black region here. I upload it to Azure to have the TIFF file. I make an Instagram, and I select that everything below this value is flooded. So I then make the mask for that. And then I do exactly the same for the year before. And I arrive to another image, which with using the same filter, the same threshold for the histogram, I get to the same mask. So which are the flooded areas of Pakistan? Those that were flooded the year of the flood and not flooded on the year after. And that's basically this is what I compare here. So on the right is the year before, and on the left is the flooded area. You can see that the region is heavily sown here. So that difference between those 2 images is this one. That's the difference, is literally here. Flood is where the flood before the year is not null, and the other is basically put as zeros. That's the flood. I do a little bit of smoothing to get that, and my answer here is 14,000 because the unit is in meters. I divide by the resolution, so that's the number of pixels multiplied by the resolution divided by the to convert from meters to kilometers, 14,000. I've done this pretty offhanded, so that's why it's probably it needs a little bit more work. Just the opposite of Qiusheng, because I don't have much time. You can do exactly the same with RGB or an infrared. You just change Sentinel-1 to Sentinel-2, and then you get red, green, and blue and near infrared. You make the cloudless mosaic by doing the median, which is this median of all the time. That's the cloudless of the period of the flood. You can also do the NDVI. You get the idea. And then at the end, you get the same mask of what is flooded and what is not. The mask of the flood using NDVI is 11,000, 6,000 here, which is much smaller. And I think this is because of the effect of clouds and because the flood is much more visible in synthetic aperture than in radar. So that's basically how you do it. But to me, the biggest point, this is the mask of SAR and this is the mask of NDVI, is that there's two steps. One, you explore the data, and then you use whatever thing you want to use, QGIS if you want, or Python or R or anything else, and then you just use your skills in Python or other tool to do the results. And the code is here if you want to take a look, and I hope, Maxim, you can post it.
Yeah, if you can share that, I'll be able to send it out. One thing I did want to just come back to is we'll bring everybody up. So one of the interesting things is, for example, when you're sharing the bimodal distribution, maybe you can pull that up, Bruno, again. I'd love to get back to that. If we go there, we can see that the threshold that you take is very close to the 0.1 that Qiusheng decided to take as well. So these little things where we end up getting very close to the same parameters as well, but they lead to differences in the analysis where the results are a little bit different.
Yes, indeed. And there's two things to highlight. One is that we work, like we have said, as you know, Maxime, we have said each other's code because this is not about picking winners or making what's the best tool of this. It's just to share that it's not about the number itself, it's how you go about it. And of course, as you exactly say here, this is something you probably can do better, but you can see that if there is time, I can also pull up the SAR data and show the histogram, and you can filter that. It's a bit harder to do with the tools I've chosen, but if you start filtering bigger, if I put 0.01, which is this peak here, then all of this disappears a lot because these are places that are a little bit flooded but not too flooded. So the more I put the threshold to the right, the bigger the area, but the bigger the risk that I'm putting places as flooded when they were not.
Yep.
Yeah, I can also add a couple more points. So because this is more like about the process, not really like in detail exactly how what kind of parameter we use. So we use a simple one, so-called global threshold. So we use a simple one.
Yeah.
But you can also use some local threshold. So there are different ways you can actually do that. And the reason that we just use a simple one because for example, for me, I use Landsat. I use like the entire nationwide composite, but there's like combining hundreds of images, and because it depends on the season, depends on the date, this global threshold is not going to work perfectly, but just shows you like some idea, and you can certainly refine. So basically, within the input and the output, what you do in between, different people can do different ways, and you can refine if you want to. But certainly, the threshold is going to change the result. The smaller the threshold, the larger area you're going to get, but the higher the commission error, because you're going to also end up with a lot of actually not water being identified as water. The higher the threshold, the smaller of the area, because you're going to have a lot of omission rate. So it's kind of a trade-off between omission and commission. And definitely that's something that you can spend more time like digging into which threshold we should use in order to make it more closely to the reality.
And that just, I want to get to Locate's press question in a bit, but just before that, I want to answer, Philip just mentioned, in theory, Google Earth Engine and Planetary Computer could do exactly the same analysis. So that's a question, but the answer is, I'm curious to know what you guys think.
I think I do. By the way, something that I had to chuckle. When you run Qiusheng's geemap on the Planetary Computer, it's a chimera, because basically what it's using is using the kernel of the PC compute to then pull data from Google Earth Engine down to West Europe to do those computations. There is nothing preventing you from using geemap on anywhere, which is true, and it pulls exactly the same bytes of Sentinel and Landsat. There is nothing preventing you to use the Planetary Computer data anywhere you want, QGIS, or even if you want to pull it in Google Earth Engine, I guess you could, because you just get the URLs and do that thing. The data is the same, Sentinel and Landsat.
And I also just goes for the analysis that's also done in QGIS. Like here in this case, it was taken from Copernicus EMS, but the way that's found is the data is the same. Comparing like Sentinel-1, Landsat, all of these programs are just freely available in a bunch of different places. So we could have exactly the same number if we tweaked it exactly the same.
If I had to if I had to do the nitpicking, the data on Google Earth Engine is changed somehow. I don't know how it's changed. It's not documented, but they changed somehow. That I think that's part of the magic why it's then so fast. The data on the Planetary Computer is not changed, and if it's changed, it's only to do calcs of.
Well, I think it's just pre-processing. Like, to jump in on there, on the SAR side of things, you have to have some pre-processing, and that leads to some slightly different results, because even in how you pre-process that data, the parameters there, the way Google Earth Engine pre-processes GRD, for example, it might be a little bit different than on the Microsoft side. So if you even take the same threshold, you might get slightly different results, but the base data is the same.
Yeah, I would love to get corrected on this if that is not the case. If you upload a file to Google Earth Engine and download it, the numbers change. The MD5 hash changes, and I don't know why.
Right, I see what you're saying. Okay.
Yeah, so basically in Google Earth Engine, the result depends on your final, for example, in terms of zonal statistics, depends on the resolution that you set. Google Earth Engine does not actually use the native resolution to do the compute. So for example, I say 1 kilometer is based on the exporting result. You say 1 kilometer, 500 meters. So the result is going to change. So if you zoom in, for example, zoom out, the area you're going to get, I mean, if you simply based on that, it's going to be different. So unlike Planetary Computer, you can use calc. Sometimes you can also pull some coarse resolution data, but ideally they should be pretty much close. The results should be similar, but it's not going to be exactly the same.
I want to get onto Locate Press is a pretty interesting question. I'm quite curious to get your take on it. So yes, I'm wondering how much each speaker would quantify how long the process takes, i.e., if they had to run it on a different area today, how long to tweak and just run in general? Do you have a ballpark of how much work it would be? Say there's next year, God forbid, there's another flood in another country. Floods happen all the time. How long would it take?
I think, correct me if I'm wrong, Qiusheng, I think for Planetary Computer Earth Engine, 0.
Yeah,
you basically change the rate of interest and you run it again.
So I think that the main thing is that it's in hindsight, you know where the area is, but there is knowing where to look at as well is something. So right now we kind of have hindsight that helps us to know, oh, there was a flood there. But let's say tomorrow there's an article that comes out and says there's a flood coming out here, and we don't really quite know where it is just yet.
Exactly, this is what we're doing this. My hope when we do this thing is that every NGO, every civil organization, when I work at the World Bank, the same thing, everyone who's listening to this and is using any of these tools, they would see the code and they know how they can do it in Google Earth Engine or in Planetary Computer. Doesn't really matter, but you can do an extremely powerful computation extremely fast with basically no cost. Because you've run this in Pakistan, which was a very large event, which is difficult to do. And my hope is that if you are only using Planetary Computer, no, you can do it in QGIS. No, you can do it in Google Earth Engine, and the opposite.
So you're saying the additional, like doing one other analysis is very easy once you've done one. Once you have the code for one, okay.
Satellites are agnostic of where they look at.
So
I would join me the same thing. So I'm not sure if you can pull in my screen sharing.
Yeah, of course.
So exactly just like the question is about like how you can run it in a different area. So if you zoom into here, this is the 5 lines code that you need to change. So you can change to other country and you just change the date. For example, if right now 2023, you can change it basically the time period. That's it. Rerun the code, everything works exactly the same. Although you can change other data layer names and other stuff, but essentially, as I mentioned earlier, the location doesn't matter, the date doesn't matter. It's the same logic. So if you have 2 time periods, doesn't matter. It's 1980, 2023, doesn't matter. It can be country, Pakistan, USA, or even at the global scale, doesn't matter. So you can run the same code, just make changes to these 5 lines, and it will work just.
That's what's so mind-blowingly powerful of these cloud GIS platforms.
Yeah, the main value of the cloud aspect is that it's not running on your computer as well, so it can pull in whatever data that you want. Granted, you
And
have
then
access to it.
yes, exactly. With the planetary computer, you can do exactly the same thing in the local version or in your own internet. The only thing is that then you will need to catalog 54 petabytes of data you probably don't want to do.
So we have Qiusheng, I think I'm probably pronouncing that right. That actually the workflow is conceptually the same, but actually the code is very different. Is it possible to write one code and run it on, I'm guessing, other platforms? There's probably
Well, I know
some
you can
specific.
run Python. Oh, sorry. I know you can run the Python code pretty decently in the console in QGIS. I tend to use an IDE for that sort of thing, but that's probably personal taste. And you can also, I use SQL an awful lot when I'm trying to just kind of write out some calculations. But I think the Python code can move around. Can it, Bruno?
The only thing is
What-
just like the access that you guys had set up. For example,
So-
at the very beginning, Qiusheng, you were showing you need to log in to Google Earth Engine and copy like a specific code. But even if you run that in VS Code, you're going to have to do it. It's probably going to run there as well.
At the end of the day, and this is the thing that I love Google Earth Engine. I think it's a fantastic tool, but it's kind of the downside in that sense. You have to use either the JavaScript environment that they provide or the Python conversion that Qiusheng created, and depends on the taxonomy that they created. With the planetary computer, because there is no planetary computer language, you can do Python, you can do R, and you can do exactly the same if you have the data locally, or if you have the data on the API server, whatever thing it is. Does it make sense what I'm saying?
We have Tyler Erickson who's jumping in on the chat, who's a developer advocate at Google Earth
Oh, Tyler,
Engine.
he's great. Thank you for helping. And as I said before he came up, I do love Google Earth Engine. I think it's a fantastic tool. But of course, I'm biased on the planetary computer.
So just Tyler mentions Earth Engine by default uses data that has been reduced, so pyramiding to a scale appropriate to your analysis. But you can explicitly request the native scale projection of imagery that you want. So that basically is the same that we were showing earlier, that the higher your resolution is, the nicer it's going to look, but the longer it's going to take. And so especially when it's showing just in the browser, you don't need something at even the native resolution of Sentinel, which is around 10 centimeters. When you're looking at the country the size of Pakistan, 1 kilometer is big enough.
Yeah, when I started this code, I had a problem. I was using the Stack, which is another framework, and it was not working because it was not able to use the pyramids. It was not able to use the overview. And there's an open issue to correct that back on the Python environment. It's going to correct things for everyone using this environment. And that's why I switched to Open Data Cube. Doing this at native resolution would be prohibitive for area like Pakistan. So it's fantastic that both planetary computer and Google Earth Engine and QGIS are able to stream COGS.
Yeah, I think.
Oh, sorry. Go ahead.
No, please.
Well, I was going to add that the problem with QGIS on a Mac is its capability to have. There's pyramiding that you can do as well, but I mean, like you said, because this is not cloud, they do have a cloud database that you can use. I forget what it's called. I think it's called QGIS Cloud or something. And you get your I know, real stretch, but you get your own database, and you can put some things there. So there was a very specific case that was very specific to this question that probably would have not applied to that many people. So I focused more on the innate part of what QGIS can do, just because that's what I can run locally if I'm going to be looking at a geography as large. Now, if I shrunk it down to maybe just one little area, and you don't mind, and what I was going to do alternatively is film it, so I could cut out all the lag so that you could see it. But that's not really how it was happening in the real world. So obviously, advantage goes to cloud computation. Even with the pyramiding that's available in QGIS, it was really not extremely efficient.
I think that raises a good point, that like one of the big differences that at least we've shown today, is that the analysis that you've done, Bonny, and everything that you've shown is just running locally on your computer. And so there's some trade-offs there where it's slower. And to go back to the question that was asked earlier about how much time would it take and effort would it take to run the same analysis again, you'd have to, it would take longer because you'd have to pull in the new data. But then one of the big benefits is that there's ownership a lot more on the analysis that you're doing. And so even if Google Earth Engine and Microsoft's Planetary Computer are, quote, free, there's still a cost of running that project. You don't really own it on the other end. You're kind of using their infrastructure. So they're quite different in their approaches. And then Bruno was showing earlier, you can also just spin up QGIS in the Planetary Computer server. And then you could also just go onto AWS, spin up an EC2 instance, and then create a Jupyter Hub, and then spin up QGIS from there. So all these tools, they're not blocked together in different areas. They're really tools that can start working together. The goal was really to try to keep it simple, and we've already done over an hour and 15 minutes just trying to keep it quite simple. I do want to ask if there's any other questions, so we can start rounding it off. I don't know if Qiusheng, Bruno, Bonny, there's anything else that you guys would like to add?
Yeah, so I mean, the goal is just to show different aspects of using, like doing the same analysis, how you get started, but it's not like to pick like one over the other. Just to be open-minded, like what's the tools out there. If you only do this one in this platform, how do you do that? And certainly they all have their advantages and disadvantages. And but it'd be nice to be able to see how you can actually do that in action. And I'm all for these tools is free, and to make things more accessible, everyone can run it, everyone can open a tab or download data to play with the data. So it's something that everyone can do to basically get some insights into some of the environmental issues that we are facing. So, and I thank Microsoft and Google for making this platform freely accessible to everyone. And this is how make it possible for us actually to present. And also, so of course, QGIS has been for over 20 years. So it's all the efforts from the community and also from those big tech. So that makes things possible for us to do things much easier and faster.
And it doesn't always have to be an enterprise solution. There's ways around that. And that's kind of why I kind of have always gravitated to QGIS, because I don't work. I mean, I work independently. I'm an author, I'm a writer, I'm a presenter, all that kind of thing. So I don't have access to. I have access to Google Earth Engine. I mean, Jefferson, he knows that, because I learned from him. So it's a very powerful tool. And when I was writing the book, sometimes though, when I was writing the book, I had to show people, here's how you do it. Here's go in your terminal. But then me innately, if I was doing something on my own, I would have just popped into QGIS real quick, taken a look at something, done a quick little calculation, and been on with my day. So sometimes they're both there, but understanding like Planetary Computer and understanding Google Earth Engine, it helps you from just thinking you can look at something beautiful like ArcGIS or QGIS and just hit a button and be like, okay, what's happening, and get a result. Understanding how things work under the hood makes you better at using some of these, automated systems. And that's all I wanted to say about that.
I would add to that also that, by the way, anyone has access to Planetary Computer. There's this login process. I guess I shouldn't say that because I'm not anymore at Microsoft, so maybe they change things. But I suspect that anyone can get access to the Planetary Computer and deploy the computer wherever they want. What I would say is that what before would have been impossible or extremely expensive is available to anyone, which is kind of magical. And please remember that platforms want users, but users should want tools. So if you use only one, there is no downside of listening and watching how the other driver is doing it in the other tool. And I would encourage other drivers, I would call them drivers, that use Esri or Planet or Satellogic or any other platforms to do something similar. There is no downside to see how something is done in other platforms. And at the end of the day, that would also help make Google Earth Engine better and Planetary Computer better. Because what better signal to give to these companies or any developer who's using in Geospatial to know that, hey, it's easy to do these things. This is how it's been this other tool. The users demand it. Let's make it happen.
I think this is a great place to round it off. We haven't had any questions in a little while, so I think we can end it here. I do want to thank.
Hey, one more thing, Maxine, before you thank us. There's a lot of tools out there in the market, and I'm telling you that you find out about them by listening to Minds Behind Maps and listening. No, I'm not doing that just to be like, hey, and check them out. That is how you learn about these things. That's how you know what tools here, what's available, what's happening. And I think that resource needs to be mentioned. And I just wanted to make sure we didn't close out without saying how powerful and useful it's been for those of us that are past our scholastic and academic years.
Well, thank you. I do appreciate that. I will put the links to everything in the description. So if people want to come back in a few hours or a few days, we'll put all of that. I hope this was useful to everybody. I do want to thank you guys for your time, because it's not just presenting, but it was preparing all the code. This has been like a few months in the making. So thank you, everybody. Thank you, everybody who's been listening. I hope this was useful. Seems like there was quite a lot of people. So that's great. Wish everybody a great day.
Thank you, everyone. Thank you, Maxime. Thank you, Qiusheng and Bonny.
Yeah, thank you for organizing this. It's very nice to see everyone. And again, feel free to reach out to us if you have any questions about the call or anything related to the things that we just presented. Reach out to on social media, Twitter, YouTube, or LinkedIn. We're happy to continue the conversation. And maybe we can make a follow-up episode.
Let's not get ahead of ourselves.
I know. Yeah.
The link to everybody's Twitter is currently in the description, and we'll put the links to everything in the projects a little bit later on. Thank you very much, everybody.
Thank you. Take care. Bye-bye.